happens if an inert gas is added to the container, but the total pressure is now kept constant. Temperature is also constant. So let's think about this. Okay, let's take 10 more seconds. Okay. We're going down into the 60s. Again, we're heading toward the 90s by the end, but this is actually new material, so that's fine. All right, so let's think about it. So the reaction it's going to shift toward reactants. Let's think about why. Let's break it down. And what was important is that hint that for the pressure to be kept constant, the volume of the container must have increased. So let's take a look at that. So if the total pressure was kept constant, if the total pressure didn't change when you added an inert gas, the volume must have changed. Let's look at this. Say oxygen is our gas of interest and N2 is an inert gas. If we add an inert gas to our system, the total pressure should go up. If it doesn't, then something else must have changed, and what must have changed is the volume. Otherwise, the total pressure would not have stayed the same. So the volume of the container must have increased if the pressure is the same. So then we ask the question, if you increase the volume, what happens to the reaction? How does it shift? If you increase the volume, if you expand the volume, then you're going to shift from, in this case, where you have 1 mole to 2 moles toward reactants. You will, as the volume increases, then you're going to have a change in the partial pressure of the gas. All of a sudden, the gas has a lot more room, and its pressure is going to decrease. The partial pressure will decrease. It has a lot more space for itself. It's like it's in there all by itself. Partial pressure, you can think of it as selfish gas molecules. They don't care what else is there. They're only thinking about how they're faring in this environment. So then we want to shift in a way that compensates for that stress, that increases the pressure, so we move from 1 molecule to 2 molecules. So it's all about the partial pressure Q and K. So again, in these questions, you have to dissect what's going on. What has changed? The questions are often phrased in such a way, something's kept constant, but if something's kept constant, you have to ask the question, to keep it constant, did something have to change for that to be true? So again, the wordings of these can be tricky. You have a question?
Yeah, why didn't it just stay was it necessary for it
Well, then that's, yeah, so the question is it necessary for it to try to increase pressure? This is just the predictive tool of Le Chatelier. Le Chatelier would predict that if the system is changed in such a way such that volume increases so the partial pressure decreases, that the system will shift in a way to minimize that stress. And to minimize that stress, you would increase the partial pressure by doing the shift from 1 mole to 2. So again, this is Le Chatelier's predicted how you would predict the direction of the shift based on the simple idea that a system where a stress is applied, the system will respond in a way to minimize the stress. And again, I talked about last time that this concept of minimizing stress is difficult for some MIT students, but you just sort of have to memorize that in this case, we're predicting how a system will shift to minimize that stress. Okay. So if you need a review of partial pressure, go over this. This part, it looks a little challenging at first, and some of the questions, you really have to sit down and dissect what's going on. And for most people, once they get there, that part, those are good questions. You look forward to them on the exam.